Good morning. Welcome to the first week one of object-oriented programming. A few things before we get started. Just kind of an overview of the presentations of the lecture videos. One of the things I want to get across is this is usually I don't, in the class I teach, worry about letting you get into the details. With the programming language, it's the opposite. Okay, the way that you learn a programming language is that you program, and we will be doing a lot of that. So the lecture videos we're going to be talking about are not basically to be writing programs. We'll do some of that in the face-to-face classes just to reinforce it, but the lecture videos are going to be more of an introduction. Okay, here's what we're going to talk about today. Here's the basics, processing, but how we really use that are going to be in the labs and in the assignments. Okay. So these lecture videos are going to be relatively short, okay, as far as the introduction is concerned. But again, the concentration of where we're going to be going is actually using and coding Java. Okay, so that's what we'll be working on. As a prefix, you should have already loaded VS Code in preparation, okay, for writing Java languages. And so we're going to go ahead and jump in, but just keep in mind that our lecture videos are going to be more introductory with emphasis now not really be placed on programming through the video, but to basically give you an introduction. So let's get started. Okay, introduction to object programming. So this is the first lecture. We're laying the foundation for everything that we'll do in this course. What you will learn what object-oriented programming is, why it matters, okay, what classes and objects are, and how Java uses these concepts to secure programs. Okay, what is object-oriented programming? Okay, programming based on objects, based on things, real things. Okay. And we call these objects. It models the real world. Okay, when we have an object that we're creating, that object actually exists in some form in the real world in our daily lives, and emphasizes modularity and reuse. Okay, modularity, reuse, putting things in pieces and then reusing those pieces. Okay, so not creating one big giant program, but creating maybe up to many model and up to many entities and many objects, okay, and breaking those into pieces. Example of that is a student, a bank account, a car, okay, and we'll get more into this. Each one becomes a class in Java, okay, distinct class. So why Java uses OOP? Okay, Java is built from the ground up for object-oriented programming. It promotes clean program architecture, supports scalability and maintainability. Java is the most widely used object-oriented program language in the industry. We have Python, we have C++, but as far as object-oriented programming, then this particular language is basically the crux of designing for object-oriented programming. The key concepts, we'll be delving in these more and more as the 8 weeks, as the 7 weeks go by. Bullet points, we're going to talk about encapsulation, we're going to talk about inheritance, polymorphism, and abstract. Don't get bent out of shape. We're going to be covering these in detail, and you'll be an expert by the end of this section, or these 7 weeks. Okay, so these are the 4 major pillars of object-oriented programming. Okay, this week we're going to focus on encapsulation, okay, and the basic classes and objects. What is a class? A class is a blueprint. Okay, a class is a blueprint. I have a car, in that car, I might have seats. I might have a steering wheel. Okay. And so that's what we have here. It's a blueprint of a class or a template, okay, of something. Okay, defines properties and attributes. Okay, defines behaviors. So the properties of a class and the behaviors of a class. A class in Java is simply a blueprint. It describes attributes and behaviors of objects. For example, a car class may have attributes of color, speed, methods of I'm going to accelerate, I'm going to brake. Again, looking at the things of the world as objects, and that's how we're going to be creating things. Okay, so what is an object? Excuse me. A specific instance of a class. Okay, we'll be creating instances. You'll find out later, we can create more than one instance, but this is taking that blueprint and actually creating an object that conforms with the blueprint that we're just talking about in the class. Okay, object is actual concrete instance of a class. If a class is the blueprint, then the object is the finished house built from the blueprint. So if the car is a class, an object might be your red Honda with 40,000 miles. That would be an object that came from the definition of the class or from the template. Example, class versus an object. Okay, visual, use a simple diagram. Okay, that diagram, let's think about dog. Dog has attributes. It could be the name of the dog, the age of the dog, the breed of the dog. And the behaviors of that particular object is, dog barks, dog eats. That object example, you can create a specific instance, okay, of this class dog, and you can create this instance and call it a specific instance called Buddy, or a name called Luna. Okay, this diagram shows the difference between dog and what dogs have. Individual objects, Buddy and Luna, fill the actual values. Okay. Again, the template, okay, and then after the template, the actual object itself. Anatomy of a simple Java class. Okay, here's the code block. Public, what is the class? What is this class name? What are the attributes for the class? Okay, in this case, we have a string name and age. And what are the methods associated? What are the things that this particular class can do? So in this particular one, okay, we have display info, and in that process, what we're going to be doing is outputting a name is whatever the age is, years old. Okay, so this is basically defining a class. Okay, you'll be seeing this a lot. But again, an introduction with a definition. Has two attributes. Okay, display, we talked about that. Creating an object in Java. Okay, so we've created the template. Okay, here we're actually creating an object, and this is the format. Student S1 equal new student. And here we're defining the actual filling in the template. The name is Mac, the age is 20, and we're going to display info. Once we do that, here, okay, we create a new student object. The keyword new tells us Java to construct the object menu. Student S1, new student. Okay, so from that, we've created the template. We've created the object. Okay, now let's talk about encapsulation. Okay, encapsulation, hiding internal details, protecting data from unauthorized access, and achieve using private fields and public methods. Encapsulation means we hide the internal workings of our classes. Okay, things that need to stay within the class and nobody should be able to get to it but that class. That is defining encapsulation, where we're encapsulating, okay, all the functionality within a given class. Here's an example of encapsulation. Okay, here we got public class bank account. We have a private balance. Okay, we have a method, okay, where we're depositing money, and we have a method where we're going to be giving the balance. Okay, here's the encapsulation. Notice that private double balance is encapsulated within bank account. You cannot access this field outside of the bank account. Okay, here, public balance. Here's a little different. Here we can actually get to the value get balance outside of the mm, yeah, outside of the out of the code block, the class. Okay. So here what can we get? We define the class, we define the template. What can we get to inside that class and what can we not get to? So that's what we're defining with encapsulation, protecting the information within the class. UML, some of you might have had this if you happen to take the software engineering course, but UML is Unified Markup Language, and it's the standard way to visualize a class. It's more of a documentation piece than anything. So UML is the industry standard way to design classes before writing the code. We create a UML defining the given class. Okay. And from those classes, we'll basically be beginning creating the objects or instantiating the objects for that given class. Why OOP matters: better organization, easier debugging, code reuse for classes, scalable, all the good stuff that we want coming out of a system. Uh, Especially once your project gets large. Okay, we're probably not going to be touching any very large projects. You will have a project, but it's going to be manageable. So, but as projects get bigger, we have the more the need to basically break that big glob of something we have to program into various pieces or blocks. Okay. And that's where we're talking about creating objects itself, which basically helps in that scalability and designing of object-oriented programming. Okay, what's coming next? Next week 2, we're going to be talking about constructors, method overloading, access modifiers, more detailed UMLs, okay, and into what we talk about when we say we're going to inherit something. Okay, so that's kind of the overview. Okay, we're going to be digging deep, okay, with your homework assignment and your first lab. And probably we'll have some assignments kind of where you can work on your project at the same time. We'll be covering those project assignments in this week's class. Okay. And for those who are online, I will be sending you your project as what you'll be working on. Okay, well, that's it for week 1. Okay, we'll see you next week when we talk about week 2, and we'll get things going. Yeah, hope to see you soon. Bye.